Hello and welcome to Tuesday's edition of Cracking the Cryptic, where today we're going to be trying a puzzle called Zip-Pea by Sujoyku. And this apparently is beautiful. It's a quite rare thing, actually. It's only got 2 stars out of difficulty, or 2 stars out of 5 for difficulty on Logic Masters Germany, and yet has achieved a 99% approval rating. I cannot tell you how hard that is to do. I would guess there are only a handful of puzzles that would have that characteristic, because when they're easier, so many people solve them, and inevitably 1 or 2 people won't award them their maximum number of marks. But obviously, in this case, almost everyone who's done it has said this is fantastic, and indeed we've had some absolutely stellar recommendations to try it. So I'm looking forward to having a go. And I will read you the rules of the puzzle in a moment or two's time. A few things to mention though, with it being the 1st of the month. In fact, I'm not going to start with anything 1st of October related. I have to share with you something that made Mark and I laugh incredibly hard earlier on, which is, I mean, we try to keep politics out of the channel, but if we could lightly poke fun at Robert Jenrick, we feel we really ought to, because some of you may not know this, but at the moment the Tory party in the UK is having a leadership election, and there are 4 candidates left, and I think it's the Tory leadership, is it the Tory conference at the moment? So they all get together, and Robert Jenrick, who is one of the candidates in this leadership election, is producing his own newspaper every day of the conference. So you can see here, this is edition number 3. If we Tuesday the 1st of October. So it's a newspaper all about Robert Jenrick. But on the back page, there is a Sudoku puzzle, and look at the row 2 of this Sudoku puzzle. Well, no, you can't do that. I mean, I don't know what to say. I'm just lost for words. But thank you to those of you who tweeted about this to us and said that we might be interested to see it. It did make us laugh. And anyway, we thought we would share it with you. There you go. And yeah, moving swiftly on. What else is going on the 1st of October apart from Robert Jenrick's newspapers? Well, big news this evening. At 10 p.m. UK time, Mark and I are streaming, and we're streaming unusually. We're streaming ourselves solving Sudoku puzzles. And these are the puzzles that have appeared in the free pack we created to sort of, oh, that's a bit too big, to celebrate reaching 600,000 subscribers on YouTube. So let me see if I can remember some of the authors of this one. I see I've not solved some of these. I remember that one was by James Sinclair. Olimar definitely did one of them. That might be Olimar there. But there's a Fistamafel in here. There's a Codec in here. I think there's a Juggler in here. I want to say a Half-Baked Lunatic. I want to say a Florian Wortman. I want to say a Piotr Vian Garford as well. So anyway, there's an absolute host of magnificent Sudoku puzzles, and we're going to try and solve some of them for you. So 10 p.m. UK time, we'd love to have your company. I'll try and remember to put a link on the screen. Now, the other big news with it being the 1st of October is it is Patreon Reward Day. If you're a patron of the channel over on Patreon, firstly, thank you so much for supporting us there, and secondly, we have a brand new Sudoku Hunt competition launching. It launched at 4 o'clock this afternoon, and it is, let me show you the picture, Halloween themed. Caroline's Halloween Adventure from the Paint by Numbers Institute. Japanese sum Sudokus, as you can see here. These are the ones that give you a picture when you solve them correctly. I don't know, it's about to go live. I'm recording this in the middle of the afternoon. I think by the time the video goes live, we will have had correct entries. People who will have finished all 10 or 11 of the puzzles. But we'll see. Anyway, good luck to you all, and let us know whether you enjoy the puzzles. We are sure that you will. Now, and some birthdays and anniversary announcements. Let's do those. Jordan and Heather, it's your 2-year wedding anniversary today. So many congratulations on that. The two of you watch daily, apparently. I hope you have a brilliant day today. And I think a wedding anniversary is absolutely adequate excuse to have chocolate cake, fully iced, of course. Now, next, Chase. You have turned 36 today. And I know this because your wife Cheryl wrote to us. And I know the two of you aren't together today because I think, Chase, you've gone to help your father recover from knee surgery. So I hope your dad's knee surgery went well and he is recovering strongly. I think knee surgery, is that the one where they make you walk on it very soon after you've had it done? So I hope all the rehab is going splendidly. I'm assured by Cheryl you'll be having your cake on your return. And, oh, yeah. I remember that you're the two who got married in Vegas. I want to... about it. No, just under a year ago, November last year. I might be wrong about that, but anyway, I think you invited Mark and I to your wedding. Anyway, thank you for the wedding invite. I think we did reply. Chase, many happy returns. Next, over there in Brazil, Fernanda, you've turned 34 today. And I know this because your husband Luis wrote to us and said that you enjoyed watching the channel. I know you've been ill with COVID. There's a lot of that going around at the moment, so I hope that you are recovering. Apparently you're going on a trip to the Iguazu Falls, a place I would love to visit. I have friends who've been to the Iguazu Falls and were sort of bowled over by it, but I have never been to the Iguazu Falls. I've been to the Victoria Falls a couple of times, which are also spectacular. But anyway, Fernanda, many happy returns. And then finally, Tom, you've turned 31 today, and I know this because your wife Alex wrote to us, and the two of you started watching in the pandemic, and you still watch every night, which is very good of you. Thank you for watching, and Tom, I hope you have a brilliant birthday today with an enormous slab of chocolate cake with a properly ratioed amount of icing, which is obviously 1-to-1 at worst. Anyway, with that said and done, let's have a look at Zip-Pea by Sujoyku. Let's hope there are we don't have any rows in this puzzle where two of the same number appear. What are the rules? Normal Sudoku rules apply, so we have to put the digits 1 to 9 once each in every row, every column, and every 3x3 box. P lines. The sum of the digits on a line strictly between two circles is equal to a concatenation of the two values in the circles in some order. Luckily, even if you don't know what concatenation means, and I wouldn't blame you, there is an example. It says, for example, 3, 3, 4, 6, 1 could be a valid split P line as 3 plus 4 plus 6 equals 13. Yeah, so the way these work, I've done a puzzle. It might have been by Sujoyku before, and it was absolutely brilliant. And the way it works is, let's look at those two digits. I don't know if this will work. Imagine this was 2 and 3. Then the digits on this line would have to sum to either 23 or 32. That's how it works. So it's pretty straightforward once you get the idea of it. And we've also got some zipper lines today. So cells on a lavender line at an equal distance to the center, which is marked with a dot. So that's a center, look. Sum to the digit at the center. Note, the circles of P lines are not part of the zipper lines. Yeah, no, I would have assumed that. I.e. the P lines are green and lavender, but the zipper lines are only the lavender parts. Yes, okay, so what this is saying is that, let's look at this line. The P line part of it applies to the whole line, but the zipper line property only applies to the purple bit of it, or lavender bit to be precise. Now, how do lavender lines work, or zipper lines? This is another brilliant rule set that's only been created in the last year or so. What you do is you write a digit here. Let's write 8. Now, if this is 8, that means these two cells, which are an equal distance from the center, have to sum to 8. And then so would those two cells. So these two would add up to 8, and then those two would add up to 8. And that's how zipper lines work. Do have a go. the way to play is to click the link under the video as usual. But now I get to play. Let's get cracking. Now, let's get cracking. Is it going to be the very long line? How long is that? Oh, I see. It's length 7, isn't it? Because the 2 green circles at the end don't apply. So these digits are going to sum to a multiple of 4, is what we can say. Which, that's probably not going to be... It's probably not going to be a massive restriction, actually, because you can have so many repeated digits along the string. Why do I say that the line must be a multiple of 4? Well, because these 2 green cells add up to the blue one. These 2 light green cells add up to the blue one, and those 2 cells, or those 2 orange cells, add up to the blue one, don't they? So as a you can see, if this was X, if we called this X, we'd have an X there for green, an X there for light green, and an X there for orange. So overall 4x would be the sum of those 7 digits on the line. We might be better looking at, right, we've got a similar line in column 9 and column 1, but this is going to be a multiple of 3 this time, isn't it? We're going to have those, and those in some disposition, but at least you can't have repeats on this line. You probably, oh no, I was about to say you probably have to have a, well, you almost certainly would have to have a 1 or a 2 in there in the ends, unless this is adding up to something like 34 or higher, which I suppose it could actually, now I mention it. Right, so what are the options here? Okay, let's do this slowly. These digits all have to be different. So the minimum they could be would be 1, 2, 3, and 4, which would add up to 10. And then that would be two lots of x, to use our nomenclature. If this is x, we're saying that those would add up to 10, aren't we? So they would be 2 lots of x, so x would be 5 in the middle. Yeah, that doesn't work. That doesn't work because the only way of putting 5 in the middle would be to surround it with 1s, 2s, 3s, and 4s. So one of these pairs would be a 1-4 pair, and one of these pairs would be a 2-3 pair. And then these, the circle, the p digits in the circles, would have to be a concatenation of the sum of these digits, which is 15. So one of these would be a 1, and one of them would be a 5, and we get a lot of clashing. The 5 would clash, and whichever one of these was a 1 would clash. So that's nonsense. That doesn't work. So we are looking at least 6 in the middle. So if we went for 6, then these sum to 18, don't they? Yeah, that doesn't work. That doesn't work. Because if this is 6, I mean, the way I'm seeing that as not working is because the sum of those digits there is 3 times 6, which is 18. I have to put 1 and 8 into the circles. But the ways of adding 2 different numbers to 6 are 2, 4, which is fine, and 1, 5, which most certainly isn't anymore. So this is restricted. Let's try 7. Oh, no, not like that. So if this was 7, well, then we've got 20. Oh no, 21 definitely won't work. 21 is terrible because 21 is going to require the circles to be a 2 and a 1. And now I've only got a 3-4 pair as a valid option because 1, 6 and 2, 5 won't work. So it's actually getting more restricted as we go to higher numbers. But oh, but hang on, this has to be 8, 9 now. Ugh. Because look, the geometry is identical. So everything we've been doing here has to apply here. And I can't have a number less than 5. No, I can't. So 5, 6 and 7 are ruled out. This has to be an 8, 9 pair. But I just want to check I've not misunderstood the rules here. 8 times 3 is 24. So we'd have to put 2 and 4. Well, that can, okay, luckily that can work. Because the 2 and the 4 would rule out a 2, 6 pair, wouldn't they, to add up to 8 from the green and the orange. But we could have 1, 7 and 3, 5. So that actually does work. which is good. So 9 probably works as well. So 9, we'd have to have 27 in the circles. Oh, that's weird. Okay, so there's actually loads of options for that. Yeah, because the options for adding up to 9 across green or orange are now only 2 7 has been removed. So we could have 1 8, 3 6, or 4 5. So there would be optionality available for the 9 wherever the 9 goes in one of these squares. But one thing that's interesting is we are always getting 2, aren't we? So this is it. When we put 9 here, this was 2 7, and when we put 8 here, it was 2 4. So there is always a 2 in those squares. There's always a 2 in these squares as well, and that is interesting. Is it? You see, one thing that intrigues me about that is that is ruling 2 out of the long diagonal circles, because effectively we've got this X-wing on 2s living in the grid. Well, let's make those red for a moment. Because one of these 2 squares is a 2 and one of these 2 squares is a 2, obviously we can't put a 2 here or a 2 here, or indeed a 2 there. I think I'm going to look at the long line first. Yeah, oh, yeah. Okay, let's look at the middle, because this being an 8-9 pair means this digit can't be a big number. So what's the absolute minimum this can be? It can't be 3, can it? Or can it? I don't believe it. No, well, actually, I'm going to put 3 in. It's so ludicrous, but I'm going to do it just to show you that could have been 3, I think. I mean, it's absurd, but you could put a 1-2 pair there, a 1-2 pair there, the other version of 1-2 there. And the only reason this fails, or one reason at least I can see it fails, is that 3 times 4, because if this is, remember this line adds up to 4x, is 12, and I couldn't put a 2 in either of those squares, and I would need to. In fact, they would need to be 1 and 2, so I get this absurd construction along the middle diagonal where every single cell apart from the middle one would be a 1-2 pair. So it doesn't work. That's quite funny. Alright, so this isn't 3. In fact, no, it can be 4. I was about to say it can't be 4 because I assumed I'd end up with a 2 in one of those, but I don't. If that's a 4, we've got 16 on the diagonal. It can't be 5, or... Oh, in fact, it's 4. That is brilliant. It's brilliant. It's 4, which I'm actually slightly shocked by. But I don't... Well, more to the point, I don't think it can be 5, 6, 7. Because 5 times 4 is 20. I can't put 2 0 into the circles. 6 times 4 is 24. I can't put a 2 into either of them. And 7 times 4 is 28. And again, I can't put a 2 into either of them. So I think that has to be 4. But 4 is weird. Ah, okay, no. Right, 4 is certainly weird where these two digits see one another, because they have to be a 1-3 pair. But actually... Yeah, okay, I'm dimly beginning to see how this works. It is lovely, this is just gorgeous setting, because now we know this line adds up to 4 times 4, which is 16, so I can write 1 and 6 into the P circles. Now, that's interesting, isn't it? Because that means what we can't do is populate these circles with 1-3 pairs. Because whichever one of these is a 1 is going to prevent us having a 1-3 pair in that box. So what I mean is, if this was, say, 1 and this was 3, then we could have done that, couldn't we? But that is not going to work because one of these is a 1, and that's going to prevent that from happening. And what that means is that we are going to avail ourselves of the fact that 4 is even, and therefore either that or that could be double. Oh, that's so pretty. Right. Oh my goodness. Right. Well, I was going to say one of these pairs is double 2. I know which one. It's this one. Because let's go. I didn't need to do X-wing logic before. I was prepared to do it to talk about this square, but I do need to do it now. Let's go back to the red squares. And let's think about the nature of this arrangement, which is sometimes called an X-wing. And the reason it's called an X-wing, I don't know if this will quite work actually, but you know, if I draw an approximate X like that, it looks a bit like an X, doesn't it? And that's why this pattern is called an X-wing. And you can see that pattern, it arose from putting 2s in the columns, didn't it, into one of these two positions and one of these two positions. But the crucial thing to really appreciate the power of the X-wing is to understand that although it arose in the columns, the really powerful deduction occurs in the rows. What do I mean? Well, the way to understand an X-wing is to ask a facetious question. How many 2s are you expecting there to be in row 2 of this grid, if we finish it correctly? Now, if you're Robert Jenrick, you might be going, 7? No. It's not 7 2s. There will, if we finish this correctly, there will only be 1 2 in row 2. And therefore, we can ask that same question again for row 8. How many 2s are there going to be in row 8? Well, there's going to be 1 2, isn't there? So we know that altogether, those grey squares there are going to contain 2 2s. But how many 2s are in the red squares? Well, we know there's 1 in one of those, and we know there's 1 in one of those. Well, that's 2 2s. So if there are 2 2s in the red squares, and there are only 2 2s altogether in row 2 and row 8, how many 2s can we put in all of those squares? And the answer is 0. 0 2s, because if you were to put a 2 here, for example, well, then you're going to have to put 2 2s there, and you can't put 2 2s in row 8. It won't work. So all of this is a very long-winded way of me saying that you cannot put a 2 here, and you cannot put a 2 here. Yet we know we need 2s along this diagonal. We need a pair of 2s, because otherwise it won't work. So we have to put them there. These must now be 1s and 3s. And these 2s are unwinding our X-wing, look, because now that can't be a 2, so the 2 must be there in column 9, and there in column 1, therefore. 2 is in one of these squares. This is absolutely beautiful setting. I have to say, I'm going to make this point actually, because I don't get to make it very often, but we do get an awful lot of puzzles created and recommended to us which are incredibly hard, and I actually think that this sort of thing, it shows off the beauty of Sudoku in a way that's just as effective, and I wish we got sent more puzzles of this sort, you know, 1 or 2 stars, but still the logic is crisp and really cool. Okay, but now I'm stuck. Let's try and unstick ourselves. How are we going to disambiguate all this? It might be that one, maybe. Ah, no. Okay, it's this, isn't it? Yeah, look at this line. Now, whatever digit I put in here, some concatenation of 2 and this digit, let's make it an X just for fun. I tried to make it a big X. So, I mean, if X is a 3, or or it can't be a 2 actually. So the next lowest digit it can be is 3. Well, that would mean these two digits sum to 23 or 32. That's clearly ludicrous. This must be a 1, mustn't it? And actually, this has to add up to 12, those two squares there, because they can't add up to 21. There's only 2 of them. But this 1 is doing things. That's a 1, that's a 3. One of these is a 1. It's probably that one, but we'll try and work that out in a minute. Oh dear. I'd be very keen to understand. So do we know what the periphery digits are? Like if I make that an 8, then we know this is a 4. This would be a 6, wouldn't it? I see an... Oh yeah, if that's an 8, where do you put 9 in the column? It would have to be here. It couldn't go on its own zipper, could it? So if that's an 8, that's a 9. If that's a 9... then this digit is going to be the partner of this digit, because they're going to go 9, 7, and then whatever that digit is, say it was a 1, then you couldn't put 1 8 as a pair here, so this would be an 8. But if that was a 6, this would be a 3. Right, so that digit is, if this is 8, it's 9, and if it's 9, it's 8 or 3. So it's 3, 8 or 9. The same is obviously going to be true by symmetry up here. Okay, that's probably not the next step then. I think the next step's likely to be this digit. That's my feeling. And sorry, and the reason for that is obviously this circle. Well, actually, I might be wrong, but I was thinking this circle is affected by the fact it sees these 3 digits, but actually it's more perhaps interesting to think about this digit, isn't it? Because this is really governing the size of these two, of the concatenation we need. So this is at least 4. And we're multiplying 4 by 3 along this zipper, because we're going to have x here, another x there, and another x there. So that would be 12. So this would be, so that's probably what it's going to be. Does that just work? Let's just think about that. We put 4 here. And then we have to do, well, this would have to be a 1 3 pair, which looks like it could be. And in fact, oh no, that doesn't work, because that's interesting. I can disprove this being a 4, because if it's 4, I can't get away with my double 2 option this time. I can't make both of those squares 2 because of this 2. So I have to do 1 3 pairs, and this can't be a 1 3 pair because of this. So 4 is out. Okay, so we're at least at 5 then. 5, 6, 7. I'm just going to goodlift it. 5, 6, 7, 8, and 9. But we need something that concatenates with a 1. 5 we can rule out. Beautiful. Because if it's 5, the zipper adds to 15, doesn't it? 3 lots of 5. Well, if this is the 1, this is also this is the 5 part of the concatenation. You get 2 5s. So we can instantly delete that. 6. 6 is going to give us 18, and this is going to be an 8, and that doesn't work because we've got an 8 9 pair in the row. This is lovely. Now, what about 7? Then we've got 21, so this would be a 2. That looks quite good, doesn't it? I think. I'm just going to put that in and think about it a bit more carefully. Because, well, none of these can be 2, so 2 5 is off the table. So we'd be looking at 4 3s and 1 6s. I don't see what's wrong with that, I have to say. Yeah, this is fine, isn't it? In fact, it is 7, because 8 is 24, and that doesn't have a 1 in it. 9 is 27, and that doesn't have a 1 in it. So it is 7. This is 2. This is not 2 by Sudoku. Let's double click our 2s and see if we can do anything clever with them. Well, no. I don't think I can. No, I don't think I can. All right. So, oh dear. All right. So we're going to have to think again, aren't we? Okay, so let's label these up. These are either 1 6s or 3 4s. Now, I'm not sure how well we're going to be able to limit this. 4 comes out of this square, so 3 comes out of this square. 3 comes out of this square, so 4 comes out of this square. 1 comes out of this square, so 6 comes out of this square. And that's lovely and everything, but it hasn't done it. I don't. Why have I got 3 options in there? I can't have 3 options and only. Why has this lost its option to be 6? Have I gone mad there? I don't understand what I've done there. I'm going to actually go back. It makes no sense to me. If that's 1, well, that can't be 1. So that, oh, so the 6 does come out of there. Sorry. Was I just missing the point there? I probably was. Forgive me. That can't be 3. So that can't be 4. Oh yeah, because I was matching off these two. That's nonsense. It's these two that match off on the zipper. Okay, so I've just gone mad. Never mind. Well, okay, it's fine, but I definitely have not. I definitely haven't got to the bottom of this yet, have I? So if this is 1, this is 6. If this is 4, this is 3. There's a lot of heavy lifting that this zipper's having to do. A lot of heavy lifting. Do we have to have? I don't know. I'm just surprised, and that may just be my own ineptitude. Or is there? Are these now completely resolved? I don't think these are resolved. It's too symmetrical for it to be resolved. I need something to point at to find out which one of these. The moment we find out which one of these is a 1, we are good, aren't we? That is the big game in town. So how do we do that? Or I suppose the alternative would be to find out which one of these is a 6. But oh, I see how to do it. I see how to do it. Okay, I'm quite relieved about that, because just my gut reaction was I couldn't see how this was going to be that helpful. But what I can ask here, which I think is a reasonable question, is where does 1 go in box 9? Because remember, we said these 2 digits added up to 12, so there's no possibility of there being a 1 on them. So the 1 is down here, and that's enough, because that is going to resolve this. So that's a 6, that's a 1. So this is a 3. So this is a 1. Now, let's remind ourselves how this worked. Or do we still not know? I think we do now know, don't we? Do we know which way up these, which way round the 8s and the 9s go now? Once this is a 6. If this was 9, that would make that a 3. If this is 8, that's a 9. So no, it's, oh, sorry. Okay, I'm going mad. I thought that would resolve it, but apparently it won't. So we're still in an ambiguity. We still have ambiguity. 6 is a bit interesting in this box. It can't go on the line that adds up to 12, because it would be double 6, wouldn't it? So 6 is in one of those 3 squares. No. No, I'm still baffled. Okay, we're going to have to think again. Where do you think we look now? We could look at, is it that number? Oh, I'm not sure. Or this number, do you think? That number is at least a 4. No, it can't be. Oh, could it be a 4 actually? No, it couldn't be a 4. Because I was just wondering whether double 2 was an option, but double 2 isn't an option because of this 2. So we can't put 4 here. And 1, 3 won't work because these would both have to be from 1, 3, and this doesn't work. So we are looking at least 5. So 5, 6, 7, 8, 9. And yeah, we might actually, maybe we can do something with this. Because this, remember, this is x, and that's x. We're looking at 3x for this line. So if this was 5, we're looking at 15 into these squares. And that would have to be a 1 here and a 5 here. Well, that might work. If it's 16, we're looking at 18, aren't we? Which would have to be 1, 8. If it's 7, we're looking... Ooh, can we rule that out? This would have to be 1, this would have to be 2. I don't think we can. 8 would be 24. That would have... No, that doesn't work. Okay, we can take 8 out of there. 9 would be 27. So this would be 2. This would be 7. Wow, okay. So I'm still no closer to understanding what's going on. That is weird. Okay, let us instead think again. Can I, at this juncture, somehow... Have I used all of the information? That is a sensible thing to ask. Let's delete these colours. Or have I missed something? These have to add to 12, but I don't think there's any restriction at all. If this is 8, 24 would be the total. Oh no, that doesn't work with a 1 here. Oh, okay, sorry. Yeah, I mean, yeah, we can resolve this now. Because if this is 8, then I've had 1 and 2 taken away from the possible ways of making the sums work. So I couldn't use 1, 7 or 2, 6. I'd have to use 3, 5 for both pairs. So that's 9. Right, that makes more sense. So that's 9, that's 8. Now we know this is 7 because we're looking at 3 times 9. So we're looking at 27 here. We should be looking at 24 on this side. That square is a 9 by dint of it not being able to go on the zipper. This, oh, so this square is 8 now, because it's the partner of 1 that can't go on the zipper here. So these squares are now in some order. We don't know the order, or I don't know it. 3, 6 and 4, 5 to complete the column. And these squares are 1, 7 and 3, 5 to complete that column. Now, we might be able to do, we can definitely get rid of 1 from there. So that takes 7 out of this one. We can get rid of 3 from here, which takes rid of 5 from this one. 1 from here, which gets rid of 7 from this one. Oh dear, that was nearly good, but not good enough. That can't be 9 anymore, so the work we did on this is not going to waste entirely. Okay, let's try it on these squares instead then, although I suspect this is not going to be as useful. That one can't be 3, so that one can't be 6. That one can't be 3, so that one can't be 6. So the 3 is definitely down here, which means the 5 is definitely up there. So this becomes a 3, 4 pair. That's weird, isn't it? That's weird and rather wonderful. Because now these have got to be a 5-6 pair. And does that do... Yeah, that's definitely doing... Well, we could ask a question about 8s, couldn't we, in this box? Perhaps that's been available for ages, but I've only just seen it. And we can also ask a question about 5s in this box, which that seems to be the only place for a 5. So we go 5, 5, 4, 3, 6. And this 4 means that's a 1. Now 1 goes with 6 to add up to 7. This becomes a 3, so that becomes a 4 to add up to 7. It's really easy to make a mistake on these zippers. That's a 6 by Sudoku. What are those digits? They are 5, 8, 9. Ah, yeah, I can do that. The 9 goes there. So 9, 8, 5 by dint of an arcane technique known as Sudoku. These are... Well, that's the 1. I need a 1 in that column. That's the 4. This is the 5. This is 7 and... Oh, 7 and 9, but we know those add up to 12. So that's 7. That's 9. This is not 3 anymore. So that's going to take... This is on the line adding up to 8. So we've got to be... Is this done? Oh, it's not done, and this is broken. Oh dear. That's a disaster. That's a... What did I do wrong there? 9. Something's gone wrong with this digit. Now that might be I've mispencil marked these squares. But I don't think it is actually, because this seems to remove all possible options for my understanding of how the 8 zipper worked. Oh dear, what on earth? What on earth did I do wrong? Okay, well let's just take a quick reversal to where we pencil marked. Yeah, I mean let's go back to where we pencil marked this line. I'm happy with this being 3, 4, 5, 6. That seems reasonable, doesn't it? Am I happy with the 7 line? I know that's made up of... There's no way that... I was wondering if I missed a, you know, like a double 2 option, but no, you can't miss a double 2 option with an odd number in the middle. So, neither of these can be 3. That's certainly true. So that means one of these is 3, which means one of these is 6, which means neither of these is 6. That's one thing that it feels legitimate to do. But I went further than that last time, didn't I? Ah, is this because there was a point when I was looking at this line when I realised I was thinking about the number 8 when I should have been thinking about the number 9. I wonder if that's what I did. Okay, that's possible, isn't it? So I think we better back up to here and then think again. Oh, and now I can't get this. It's not 4, 8, so it's either 3, 9 or 5, 7. 8 is still very legitimate to be placed in this box. That's fine. 9 is still very legitimate to be placed in this box. We get the 9, we get the 8. This square can't be a 1 because of the 1 in the corner. So this loses its ability to be 6 now. Now, can we do any better than that? Well, in this box, the 5 is certainly in one of those 2 squares. And that must be opposite a 4, mustn't it? So this must be a 4, 5 pair. This must be the 3, 6 pair, and we know the order. So this becomes a 4, that becomes a 3, that becomes a 6, and that becomes a 1. Oh dear, this is going to go wrong again. That's a 5, that's a 4, that's a 5. This is a 3 by mathematics. So that's a 1 and that's a 7. So this is, oh, that's going to be interesting. Yeah. Oh, no, it doesn't. Oh, I thought that was going to resolve this. But it doesn't. 15 still works. That would be a 5. 18 still works. This would be an 8. Oh, this can't be a 5. Actually, it can't be a 5 by Sudoku now. So let's get rid of that. 7 would require a 2 here for a 21 total. Bobbins. Okay, that all seems like it works. Okay, well, let's go back over here and see why this isn't working. That's a 6. That still seems to be legitimate. 1, 4, 5 into this column. So this is 5 because it needs to be part of a 12 pair. So this is 1, this is 4, this is 9. I don't know. This digit is different this time. This is the other way up. Oh, but that's because I did this first. So I'm still not convinced. Oh, this is going to be interesting to see whether... my gut reaction is there was a point in my brain when I realised I'd been thinking about 8 on this line. And I wonder if I did the maths wrong when I spoke about that. If so, no doubt lots of people were shouting at me, and I hope you can forgive me. We'll call it a Robert Jenrick moment. Now, there's a 4 in one of these squares. Then there is, oh, I've already pencil marked 5 in one of these. It must be this line now, I think. Possibly. Yeah, in fact, maybe we look at this square. Because that square must be lower than whatever digit we put on in the middle of the zipper, mustn't it? So even if that's a 7, this can be no bigger than 6. And it can't be 1, 2, or 3 by Sudoku. So it's 4, 5, or 6. And I don't think it could be 6. If it's 6, that implies this is 7, and this is a 1, which it can't be. So that is 4 or 5. And this digit is the counterpart of 4 or 5 that adds up to 6 or 7. Which is, and it can't be a 1, so it's 2 or 3. Right, let's try that one instead. Yeah, this one's also interesting. Most of its options are removed. It's 3 or 5, isn't it? It's got to be lower than this. And it can't be 1, 2, 4, or 6. So that's 3 or 5. If that's 6, that's 3 then. If that's, oh, it can't be 4 because of this. So the only way that this is a 3 is if that is a 6. And if that's a 5, this would have to be a this would have to be a 2. It can't be a 1 because of this. So this is a 2, 3 pair apparently. Unresolved. So the rest of the digits in this row are 4, 6, and 7. That's very interesting, but appears to do absolutely nothing. Where is 8 in this box? It seems to have to be there. Let's put 8 in. That gives me an 8 down here. So what digits do we need in box 7? We need 3, 5, 9. Ah, 9. I can do the 9, look. So these are 3, 5. Whoops. These are 2, 4, and 7. Let's get rid of the corner pencil mark. These squares are 5 and 8. These squares are somethings. 3, 6, 9. And that can't be 3. Oh, I see. Look, I've got a 3, 5 pair here. So that can't be 5. That's 4. This is not 4. So 4 in the top row goes here. That's not 4. That is 4 now. How many 4s have we got? A lot. That's a 4. That's displaced to... Oh, that's done it. That's displaced to 2, which is now looking at that. So that becomes 8. We're looking at 18, not 81. So this is a 6. And this kind of... So we're looking at this being a double 3. That's a 2 to pair up with the 4. This is a beautiful puzzle. 3... this 8 is very lovely. 8, 5. And what are those squares? 5. They're 5 and 8, aren't they? That's what my scanning is telling me. I hope that's not wrong. 5 and 3. In this column, what have we not got? 6. So that's a 6, that's a 6, that's a 9. That's a 6. How does this 2, 7 work? Is that resolved by something? I can't see what it is. Those squares, let's look at them. 1, 7, 9. So the 1 goes here. The 7 goes here. The 9 goes here. And now these have to be, the 5 is placed. That's been available for a while. I just didn't see it. And then these, this is 9, this is 2, this is 2, this is 7. Oh, it's still being difficult up here. Look, this is a 7, 8 pair, is it? Okay, and they should be 5 and 9. Which are, I see, that does resolve it then. 9, 5, 5, 8, 8, 7. Wow. That is so spectacularly good. It's brilliant, isn't it? What a brilliant puzzle. I'm so sorry for the ricket in the middle. I don't know what I did. In fact, I don't even know how. I think I'll have to look at the replay and see what I did. But I've no doubt there will be comments alerting me to my inanity. I apologise greatly. It's because I tried to do that Sudoku earlier that had 2 6s in row 2. It's thrown me completely. Anyway, what I can say is sujoyku, that was joyful. I think that's always what I say about when I do your puzzles. I just find them fabulous every single time. It's gorgeous. And my favourite bit was I saw the possibility of an X-wing. And I saw it had a possibility of affecting this digit, but I didn't look at it very closely. But once you got this as a 4, and I realised I couldn't put 1, 3 pairs into all of those, and I needed a double 2. And then I realised the X-wing resolved it. Oh, that was sick. Absolutely brilliant. Loved it. Let me know in the comments how you got on. I enjoy the comments, especially when they're kind, and hopefully we'll see some of you for our stream, which might now be not very far away. See you soon on Cracking the Cryptic.